With that, I do want to say welcome, Guy. Guy is a developer advocate at Redis. We're really excited to have you. Let me
stick my head into the camera here. Yeah. Are you going to be in London next month too?
I will not be in London.
Oh,
will you be in London?
I will be in London next month.
I hope you have a great time. But will you be in Copenhagen or Melbourne?
No, I won't.
Okay. Well, maybe we'll catch at a different.
I wasn't sure if you'd gotten in at NDC London or not.
I had not. I think I forgot to submit, honestly.
Well, there's your problem.
Yes. Oh, by the way, the Momentum call for speakers will be opening on May 1st. So I'd highly encourage all of you to submit a talk. If you don't know what to talk about, I'm sure you can come up with something. Just contact me and I'll help you come up with your talk idea, and we'll write it all together. So it'll be a lot of fun. With that, thank you, Guy. Have a great time. And I'm really looking forward to this.
Thanks. And if you're worried that you might not know something worthy of giving a talk at Momentum, just realize this. I was going to give this talk at Momentum. And I don't know what I'm doing. So welcome, everyone. This is my talk, Codex, the impact of English, the impact of English on programming languages. This is a little tiny keynote that I did for JavaScript and Friends a couple of years ago. There's this risk that you run into when someone says, "Hey, Guy, give a talk. Can you give a talk?" It's like, well, what would you like a talk on? Whatever you want. Whenever someone says that, you get a weird ass talk. And so what I did, I was asked, could you do a lunch keynote, like maybe 15 minutes? And I'm like, yeah, sure, I could do that. What do you want? I don't care. So I'm like, oh, I want to talk about how language impacts programming, like how English impacts programming languages. And so I did a little tiny keynote talk. And so what I've done and then it didn't get recorded and no one knew about it. And there's just sort of like this legendary talk that Guy once did that was never recorded. And so I decided, well, I'll write up an abstract, and I submitted it to Momentum, and then I had to withdraw it for various reasons. And Michael has been badgering me, I think, for 1.5 years to do this talk. So I took that little seed of a talk, and I've expanded it out a little bit. I finished my slides at like 9 o'clock last night. I haven't rehearsed. So you're getting the raw, unvarnished version of this talk. So about me, because that's my favorite topic, actually. I joke that the reason I became a developer advocate, which is what I do, I'm a developer advocate at Redis. And the best thing about being a developer advocate is that it lets me monetize my narcissism. So, but what I do there is I come out in communities, and I typically give talks about Redis. Tonight's not really a talk about Redis, but I work there, and we got cool stuff. And I got the shirt that says Redis in my heart on it and everything. So go check our stuff out. It's really cool. But tonight, I'm just going to talk about 2 of my favorite things. Before we get to that, a big, this is a talk about linguistics and programming. A big caveat. This stands for something. What's everyone think this stands for? You have to say it like Yoda, if that helps. A linguist, I am not. I was going to go with I am not a linguist, but then that comes up as I anal, and that just seemed like a really crappy .NET interface, so I decided not to go with that. So a linguist, but I decided to make a joke about it anyhow. So I'm not a linguist, right? I'm a developer. I have a linguist as a hobby. I've watched a lot of YouTube videos, read some books, stayed at a Holiday Inn Express. These are my credentials in linguism. I don't even know the word for it, right? But it's not my area of expertise. I'm a software developer. I'm a developer advocate. I've been writing software for decades. But I like languages, and I've studied a fair number of languages. I studied Latin in high school. I've studied Spanish more recently. I speak English, and I've studied the evolution of English over time. And so languages are just kind of cool and neat, and I think they're interesting. And so I gobble up a lot of content about that. And I think about programming and how programming languages are also a language, but they're not, but they are. Like, ever have anyone tell you, well, a programming language, that's like knowing another language. Like, no, it's not. JavaScript is way easier to learn than Spanish. Right? Spanish is not, for an English speaker, Spanish isn't the hardest language to learn, but it takes a lot of practice and to really become fluent in a language. JavaScript's basically in English, and you're kind of doing it a different way. And so these are interests of mine. Language. This is a picture of an Etruscan monument that I took at the British Museum. And I just thought it looked cool. Sort of says language. I like old character systems too. They're kind of fun. Like, where did the letters that we use come from? And who put the alphabets in alphabetical order? Things like that. It was the Canaanites, by the way. But I'm also a fan of programming. I've been writing software for a long time. Of late, it's mostly been JavaScript. But there are, I've done a lot of languages over the years. I started my career back in the early 90s as a shock and horror COBOL programmer. I did that for a year and a half. It was on DOS, so at least there was that. So I've been studying language for a lot of years. I've been studying programming languages for a lot of years, and I kind of asked this question, how does English impact programming? And so that's what we're going to explore. And I've kind of touched on this idea already, but is the question of, are programming languages languages? I kind of feel like they're not. They're not doing. They are and they aren't. And I'm going to make an argument that says they are, but they aren't at the same level of difficulty as a spoken language. Just because the vocabulary of a spoken language is so much greater. You have to learn thousands of words in a spoken language. English has how many tens of thousands of words do you have to know to speak English effectively? How many words do you have to know to speak JavaScript effectively? Well, there's return, and there's number, and there's not as many symbols to learn. So this actually has another question buried under it. And I promise my slides won't all just be questions, which is how do languages impact programming languages? And then it's like, well, are programming languages languages? What the heck's a language? And that seems like a good place to start at the beginning. And so languages are made up of two basic things: symbols and a grammar to stitch those symbols together. If you think about how a compiler works, compiler goes through and tokenizes your source code. It's finding all the symbols. And then it takes those symbols and says they have to be arranged in a particular way, a grammar. Now, I think programming languages probably are languages by that definition. What are symbols? Well, I watched this great YouTube video. It was a TEDx talk on the origins of language. And he was kind of exploring this idea of, did Homo erectus have the capability to speak languages? It was an interesting thing. I think his name was Dan Everett, to give him credit. And so this is kind of cribbed from his content a little bit. But he had this idea of symbols evolved from what he calls indexes or indices. An index is something that represents a thing that's in the real world. So a footprint means there was a foot here. That's an index. It indicates that there was a foot. Or maybe you hear a noise, right? That indicates that noise is an indication of a thing, that you know what it is. Or maybe the example he uses, if you smell smoke, it could be something you smell. The smell of smoke is an index for fire. Indexes turn into icons. An icon it's a drawing. It's a representation of the thing that's attempting to mimic it. So this is a picture of a foot. That would be a reasonable way to represent a foot. And then you have a symbol. And a symbol is a thing that represents a foot that is devoid of any relationship to that original thing. It's arbitrary. Now, in the case of this Chinese character for foot, I don't know the Chinese word for foot. I think it's zhu or something like that, or zhu. That's the sum total of all the Chinese I know. Well, and shishi. That's all I got. But this, is a pictographic symbol of a foot. And what I suspect is that this right here is the foot, because it looks like a little dude and that's like his leg coming back. It's kind of what it looks like. I don't know if that's the evolution of that symbol or not, but it kind of looks that way. So there's a little bit of relationship. But the symbols are devoid, for the most part, of any relationship to the thing. They may have evolved out of it, but they're devoid of it. So in English, the symbol for a foot is that. It's those 4 letters, F-O-O-T. That is a symbol for foot. That has nothing to do, it doesn't look anything like a foot. But that's what it means. That's kind of what a symbol is. Symbols don't have to be visual, although in programming languages they usually are. I can't think of an example of a programming language where the symbols are non-visual. I can't imagine like auditorial programming. It's kind of a weird idea. For example, the index of something audible would be a bird. Wonderful natural bird. By the way, this is what my wife always calls Giant Eagle, the grocery store chain. She calls him Big Bird. Am I allowed to talk about Giant Eagle at Kroger? They're terrible. Unless they're a Redis customer, in which case they're wonderful. So, a bird, you hear a bird, you hear a tweet, 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 tweet in the background, right? Except birds don't really say tweet, tweet. They say something, they do their own thing. And then we'll take that and we'll mimic that sound. That's an icon. So chirp, chirp, chirp. That's our impersonation of what a bird sounds like. And then over time, that will change into a symbol of how we say bird. This is pájaro, which is Spanish for bird. For those of you that no habla español, El Niño is Spanish for the Niño. Yeah. And so that sound, possibly, we really don't know the history of language because no one wrote it down and it doesn't fossilize well. But this is an idea of how languages could have evolved. Indexes, things that sounded like a thing, became icons, which was an imitation of that thing, which became arbitrary symbols after evolving over time. Our particular set of symbols has a long history. And even when we go back to the very base of this tree here, they're still just symbols, right? So like over here's English. I like that it has sort of a smile on it. Right? It looks like it's got a couple eyes and it's got a little half grin. And this is showing where English came from, and up here is Spanish. And they all go back to Proto-Indo-European, which is a language that we've reconstructed by studying the parallels between all the spoken languages. And even in Proto-Indo-European, the word for bird doesn't sound like chirp, chirp. It doesn't sound like the sound a bird would make. I don't even know how to do the sound a bird would make without saying tweet or chirp. Right? And so, but it goes way back. And these symbols just evolve over time. That's why the word foot doesn't look anything like a foot. And it doesn't sound like anything that a foot, what would be the sound of a foot? A squish, maybe? But it's kind of neat. These are where our symbols come from, and that evolutionary process makes them arbitrary. I want to draw a distinction between symbols and graphemes. A symbol is something that represents a thing. It's a thing that we can use. We say them, we read them. A grapheme is a single character that you can draw specifically. So foot is not a grapheme. It's made of 4 graphemes. Well, 3. One of them's used twice. But the symbol for a foot in Chinese is a grapheme and a symbol at the same time. So they can be both. So some symbols are also graphemes. Some symbols are made of multiple graphemes. Our particular set of graphemes, we all know these, right? A through Z, we all know our alphabet. Should I read them off to stretch the... It's like I'm doing a report for school and I'm like, I need to put some extra words in my talk. I know how to get 26. Yeah. And this particular set of symbols that we use, I said symbols, this particular set of graphemes that we use have also evolved over time. And originally they were symbols for things like A was an ox and B was a house. And I don't know what C was. But and over time they've evolved, and they've evolved from. Well, actually, it's kind of cool. Does anyone know where the Latin alphabet comes from? Yeah. Well, it was chiseled into stone at one point, but like the origin of this, the letters themselves, like where did the letter A come from? Phoenician. That is a good start. That's almost to the far back as we know. The modern Latin alphabet was, of course, derived from the Latin alphabet. It's just, it's what the Romans used with a couple extra letters. The Latins were a tribe in Italy, and to the north there was a larger tribe, the Etruscans, in what's today called Tuscany. The Etruscans were the powerful nation that dominated the Latins. Now, that got turned on its head because eventually the Latins became the Romans, and then they kicked everyone's ass. But the Latins got their letters from the Etruscans because there was cultural dominance over them. Fun fact, by the way, the letter C and the letter G, the letter C in English was originally came from Latin, and in classic Latin pronunciation, the C is pronounced like a K. And so Latin doesn't have a K, they don't need it, they have a C. But C came from Etruscan, where it was Etruscan didn't have a G sound. And so they used the C for both the C and the G sound. Because C was originally gamma in Greek. And so gamma, which is, I don't have a drawing of it, but it's the one that looks like a hangman's noose, right? Or not the noose, the hangman's, you play a game of hangman, right? That part. The upside down L. That's a way better metaphor. Rehearsals, so important. But it looks like that upside down L. In Greek, that makes a G sound. And in Etruscan, they use that for a K and a G. And then the Romans got the gamma from Etruscan, and they're like, well, we need the C sound and the G sound. And so they put a little loop on it to distinguish them. And that's why they didn't have the K, because the Etruscans dropped the K because they didn't need a C and a K. They didn't need a gamma and a kappa. So Etruscan came from ancient Greek, the gammas and the sigmas and the phis and all that. And the Greeks got their letters from the Phoenicians. The Phoenicians were also known as the Proto-Canaanites. So the Proto-Canaanite language. The Phoenicians were a Canaanite people, and so they used that alphabet. And the Canaanites were a Semitic tribe in that part of the world. And it is believed, but not certain, that the letters and the characters they created were actually a simplified version of hieroglyphics. So hieroglyphics have a mechanism for writing things phonetically in them, like foreign words. And so they took these simple symbols and then adopted them to be, well, these are the sounds in our language, and then they stylized them and made them easy to write. And so the modern Latin alphabet that we use today is, it is believed, a direct descendant of Egyptian hieroglyphics, which I think is just cool as hell. And it's not just the modern Latin alphabet, because these alphabets forked over time. And I don't have a cool chart of it, to things like modern Arabic, and it made it all the way into India. So a lot of the Indian scripts are derived from this. And so this one innovation forked out and created thousands of scripts that are used across the globe. It's really cool. Our numbers are graphemes too, but they're also symbols. Like 2 is a symbol. It means this many. But when you combine them together, it makes new symbols. And so numbers are kind of neat. And some things are graphemes. They're also symbols in English, right? We use these all the time. We use these in our programming. Plus and minus. That's a symbol that means addition and subtraction. Ampersand, the @ sign, the octothorpe, the $sign. Yes, a hashtag is called an octothorpe. If you've learned anything tonight, know the word octothorpe. Yeah.
I think C octothorpe is a great language.
C octothorpe, yeah. But there needs to be a better way to say flat. Yeah. C octothorpe, that's fantastic. It doesn't roll off the tongue on Twitter though, right?
No.
The Octothorpe tags. Yeah, that just doesn't. Remember before Twitter, we used to say that was the pound sign, and now it's the hashtag sign. It's actually just hash, but we put the tag on there anyhow because you're tagging your tweet with a hash and the fun stuff. And so, looking at all these symbols and all these graphemes, well, if a language is a bunch of symbols composed with a grammar, and does our code work that way? Is our code a bunch of symbols composed of grammar? And I would say our code is nothing but symbols. Right? That's all that's in there, right? And there's these symbols that are influenced by English, dramatically influenced by English. Like every word on this screen, except for the punctuation, which are also symbols, is in English. There's the words that I choose, right? I've got my little Fizzbuzz function here. We're going to be looking at this more. Our class, I've got a transform function. I've got an argument called number. I'm returning hard-coded strings that are Fizzbuzz, which I don't know if Fizzbuzz is technically English, but fizz is a word and buzz is a word, and they're kind of onomatopoetic, but I'm not sure that Fizzbuzz is a word, but we'll go with it. They're close enough to English words. So these are all English words that we're using when we're writing a code. Now, if I was a programmer writing in Spanish, I could replace these things that I'm adding to the language with, you know, I don't know, fizzo buzzo. I mean, would that be Spanish for Fizzbuzz? Right? I had a friend who used to joke that the Spanish word for alarm clock was alarmo clocko. I might choose a different name for my transform function. My, number would become, numero, right? You change those, but the English is still in there. The word class is still there. The return is still there. All these reserved words in the language, the syntax of the language, they're the symbols of the language that are part of that language itself, not the words we're making up, are also English symbols. And in fact, so are the numbers, so are the equal signs, although those are a little more universal. These are all symbols. So from a symbol point of view, if languages are made of symbols, then programming languages pass on that count. Now, this is into territory where I'm just starting to make stuff up because it's how I think about it. I don't know that these are real words, but there are, in my thinking, in my reckoning, there are two types of symbols. There are monographemic symbols and there are polygraphemic symbols. Monographemic meaning made of one grapheme. Polygraphemic meaning made of many graphemes. And so the dollar sign is monographemic. You draw a dollar sign, it means what it means. The keyword let in JavaScript, and yes, I should have used const, is polygraphemic. It's a symbol that's made up of multiple graphemes. And this is just sort of something that I've thought about languages, about programming languages, is some programming languages are more weighted towards using monographemic symbols, and some are weighted more towards using polygraphemic symbols. And just to see if you're paying attention, can you think of a language that errs on the side of being monographemic? Yeah. APL. It's funny that you mentioned APL. Yes, that is totally the right answer, and I'll have APL slides later. I'm thinking of another one that you get in trouble every time you use it. Haskell? No. This is way more common. Regular expressions. Right? And so I have this idea that there's sort of a continuum of how polygraphemic or monographemic a language is. And so on the far left, you got like APL and regular expressions, where you're just using lots of individual characters or graphemes that mean something. And then as you get further to the other side of the spectrum, you get into languages that they're less monographemic symbols. They're less punctuation, and they're more words. And so you get things like Ruby, which is a little more lighter on the punctuation. Like, oh, you don't have to put the parentheses in there. No, we don't need, any kind of terminator for the end of our line. You can get really light with it. Or COBOL, which is sort of the king of this, right? And so, anyone tell me what that regex does? Exactly. Actually, it parses out the phone numbers. Good call. You, sir, are hired. Yeah, but the point here is that if it's monographemic, it's hard to read. Most of the languages we use sort of hit a happy medium. You know, things like, I think it's telling that JavaScript, Java, C#, C, C++, and all of these, even like Swift and other programming languages like that, all are mimicking. They're the most popular languages in the world. And I can't help but think that's because it's hitting that sweet spot between enough punctuation, enough monographemes that we can pull it apart, but not so many that we can't see the symbols. And this in itself is actually a bias of being an English speaker. Well, probably more of a bias of being a Westerner, because most Western languages use the same punctuation or very similar punctuations. But it's just harder to parse something that's a bunch of characters. I wonder, I don't know, I don't speak Chinese, I don't read Chinese, but I wonder if regexes are easier if you're accustomed to dealing with simple single characters and parsing it at that level. I wonder. Don't know. I mean, I'm just hypothesizing. I have to ask someone and find out. But then how do you measure the easiness of it? I guess you could do a test. This would be a great PhD thesis. But I think there's a sweet spot. And then you got something like COBOL, where this is how you do addition. And anyone do any COBOL programming in their career? A little bit? Okay. Yeah. Now, in practice, people tend to just type compute instead. But you can say add value to number giving new number. It's a sentence. Yeah, this is totally valid COBOL syntax. It doesn't have to be nowadays, but by tradition. And I've got a gray beard, so I have to enforce the tradition of all caps in COBOL. I didn't put a line number on it, so there's that. But so, you know, there's sort of this continuum. And so this is kind of how I think about languages. And when I think about languages that are going to be successful, I think it's interesting that the most successful ones are kind of in the middle of that. And the ones that are a little that lean a little bit towards the poly or monographemic tend to be a little more boutique or hipster, right? You got, Ruby's kind of a good example of that in a way. I'm not picking on the Ruby people. That's not the intention. I actually like Ruby. But when you go that direction, it's, you know, it's kind of that way. And you go to other languages like Rust, it starts getting a little heavier on the symbols. I guess there's just like these languages on the edges kind of, and then you go beyond that and it's like no one wants to work in them regularly because they're not practical. There's a sweet spot. I think that's kind of neat. Do I have a point? No, it's just neat. And so here's our Fizzbuzz example. And so this is just a slide to sort of reinforce what I was saying here. If we look at this code, it's got that balance of monographemic and polygraphemic symbols that makes it easy for us to parse. Whereas if you look at a body of text, it actually tends to lean more towards being polygraphemic for English speakers. This is from The Doom That Came to Puppet. Have any of you heard of this? Someone took the writings of H.P. Lovecraft and mixed it with a puppet manual. Puppet, I'm not a DevOps person, but it's like an orchestration thing, right? And it's a little bit dated. And so they mixed it together and you get these great quotes. And I've highlighted all the punctuation, basically, all the monographemic symbols. And so we got Earl Sawyer suggested that help may be asked from Aylesbury or Arkham, but others maintained it would be unnecessary to know the origin of the symbols if, as he suspected, they were used as a temporary measure while renaming variables. At length, they emerged onto a muddy road to find the server, how to authenticate it, and more. It's just so great. I love that the name that was generated was At the Modules of Madness. So, metaparameters are parameters that work with any resource type. They are part of the actual, though unrecognized, mirage of the dead city. So English is actually slanted towards, you know, these polygraphemic symbols. Chinese is the complete opposite. Now, this says in Chinese, according to Google Translate, I just typed in the doom that came to Puppet. And then I said, give me Chinese characters, and it did. And I said, that must be correct. I have no idea if this is correct or not. But, you know, some languages are using these monographemic symbols throughout. And this impacts the type of programming you write. So these are types of symbols. Oh, I know what I wanted to say here. There's actually an interesting thing. You ever wonder, actually, I'm going to wait for this point because it comes better later in the talk. So that's all. That's the sum total of my knowledge on symbols. I think they're kind of neat. Next question, what's grammar? And do programming languages have grammar? Too long, didn't read. Yes, they do. They're what you get when you build the abstract syntax tree. You parse all those tokens and then you build the tree. The tree is the grammar. There are two main types of grammars that I'm going to talk about. There is positional grammar. This is where the words have to be in a particular order. In English, it's subject, verb, object. So the subject is the first word, the verb is the middle word, and the object is the last word in a three-word sentence. So in this example text here, the node writes a byte. We've got some articles in there, but you know, we can ignore those for purposes of this. Positional grammar says that the grammar is it's in an expected order. We do that all the time. There are exceptions in English. Like you could put a prepositional phrase at the beginning of a sentence. You know, with the doom that came to Puppet, the node writes the byte. Right? So you put that preposition in front. But for subject, verb, and object, it's SVO. Not all languages work this way. This is a bias that English has that shows up in code. You know, German famously has, what is it? I don't know German, so I can never remember the order. But it's got a very different one. But perhaps the most famous alternate word order in positional grammar is Yoda. A byte the node writes. Right? So Yoda is using a different positional grammar. This is subject or object, subject, verb. I don't believe any human language actually has this, which is, I think that's why George Lucas picked it. I don't know. Who knows why he does what he does. Right now, I think it's probably $1 billion is why he does what he does. But that's a pretty simple idea to understand. In a programming language, a positional grammar would say this has to be followed by this, has to be followed by this. But there's another way to do, another type of grammar, and these create sort of a continuum as well. There's inflective grammar. And we have some of this in English. This is when you change the word or change a part of the word or add or modify that word to change its grammatical context. In English, we do that with plurals. The nodes wrote the bytes. Nodes are now plural. We put an S on the end of it to say it's plural. That modifies the word node, makes it a little different. So now it's inflected. It has a change on it that tells us grammatical information about it. This is plural, not singular. Bytes, plural, not singular. Write became wrote because I made it past tense. Perhaps not the best example because write is a strong verb, which means you got write, wrote, written. But if you were like, I'm trying to think of a non-strong verb now off the top of my head, and I'm failing. Because all the common words in English tend to be strong words. But the inflection was change the vowel sound in the middle. And then that changes whether it's past, present, or future tense. Oh, past. It changes the different past tense. Present are two different past tense in English. I guess it would be so write is present, wrote is the simple past, and then written would be like the past participle that you could use as a verb or as an adjective and all those things. But anyhow, so we change the word a little bit. We inflect it to change its grammatical meaning. We do that for plurals. We do that for tensive verbs. But one thing we do it also for is in possession, like Bob's Burgers. That apostrophe S, that shows possession. So we do a little bit of this in English. English is mostly a positional grammar, but it has some inflections. And different languages have different degrees of positional and inflectiveness. I put Chinese way to the right because I've been told it's a very positional language. And they don't have a lot of inflections on their word. So like they don't always use plurals the way we do. They don't have, people say Chinese doesn't have a past tense. Well, that's because they have a verb and then they use another word that means in the past. Like they have a word that means this is a question. You put ma at the end of it. I guess that's the third Chinese word I know. But it's all positional. English is mostly positional, but has some inflections. I think Spanish is actually a little more inflective simply because their verbs are so the verbs in Spanish are just, there's a lot of variation there. And then you've got like the way the pronouns go versus when they're the object, they go before the verb. It's kind of weird for an English speaker. But it's still positional. But then you have something like Latin. Latin is a highly inflected language. And this is where I wanted to mention the point that, do you ever wonder why? In Asia, and in Chinese in particular, you tend to have these pictographic languages, and why in the West, you tend to have these languages that use alphabets. So the reason, according to the History of English podcast, where I've got this information, is that when those languages evolved, it's hard to write inflections on words with a single symbol. So if you don't use a lot of inflections in your language, then you can say, well, this is a symbol for this, and this is a symbol for this, and this is a symbol for this, and you can just string along, and it works great. But if you have a language where it's written, then I have to indicate somehow that knowledge on there. And it's easier to use an alphabet because then you can just write how it sounds. And so the idea in Proto-Indo-European, even though English isn't super highly inflected, Proto-Indo-European was, and all the languages in the West and most of them in India as well were derived from Proto-Indo-European. There are a couple of exceptions in the West, Basque specifically. But they lost my train of thought there, sorry. But since all those languages are inflected, when the alphabet started being created, that was the right tool for them. So that's what the History of English podcast says anyhow. I think it's a good theory. I'm gonna believe it. So given that we got grammar here, and the programming languages clearly have a grammar, right? When we compile them, we're building abstract syntax trees to reflect that grammar. This comes up with an interesting question, which is sort of the thing I wanted to try out after exploring all this is, what would a programming language look like if it hadn't been invented by a bunch of English speakers? I think this is a neat question. I think it's the kind of question that can get us to think about programming languages differently. Those are always fun questions to ask. So I'm going to ask the first one, and this is actually a pretty easy one, which is, what if the Chinese had developed programming languages? And my thought is since they've got characters for everything, all the programming things would just get characters too. Like this isn't a character for a conditional branch. This is a character for an assignment, and this is a character for, you just create new characters. I mean, how many are in Chinese? There's like 60,000, I think, characters in Chinese. What's 20 more in some regards, right? And so I think that would be an obvious solution. But of course, I'm a Westerner who speaks English, and so it's hard to say. But what's interesting is that someone has sort of created a language like this. It's very Western, but it does use these monographemic symbols. And that language, you nailed it earlier, is APL. This is Fizzbuzz in APL. Isn't that obvious? And so it does have some symbols because it's Fizzbuzz, and so Fizzbuzz and Fizzbuzz are in there, and those are English words, obviously. But most of these are, and it's got some parentheses and some curly braces and stuff like that. But most of these APL is actually made up of special symbols. Now, there's symbols that are derived from Western symbols. So like right here, we have a lowercase omega. All right. Here we have a couple of dots. I don't know what that, I guess it's kind of like a diacritic. Here, this is an iota. And so there's Greek letters and there's equal signs, and then there's like pipes and things like that. So it's familiar symbols, but each of these symbols means something in the programming language. And I'm going to explain how this Fizzbuzz works. I think that if the Chinese had invented programming, it would look more like this. Maybe not exactly like this, but it would have this sort of monographemic symbology to it. So to break this down, this is the first line of APL code, the first portion of it. So what this means is on the left, you have an array. And on the right, you have a number. And there's a symbol in the middle. And all of the operations that you can do in APL either have just a symbol and something to the right of them, or a symbol with something on either side of them. They call them, those first ones are called monadic, which has nothing to do with monads. Don't ask me what they are. I don't know. And the other ones are called dyadic. It's basically like saying, well, this function takes one parameter, it takes two parameters. It's really kind of talking about the arity of the operator. But they do different things depending on whether you use them monadically or dyadically. So if you like do the pipe symbol dyadically, what it does is it returns the remainder. So what I'm doing on the left is I've defined an array with the numbers 15, 3, and 5. Those are special magic numbers for Fizzbuzz, right? They're the multiples you're checking for. And then that little pipe symbol is called the residue symbol or operator. And what it does is it computes the remainder of 50. So 50 divided by 15 remainder, 50 divided by 3 remainder, 50 divided by 5 remainder. And if you run this, it will return an array of 5, 2, and 0. Because 50 divided by 15 is going to give you 5 left over, because 45 and 5. Right, you get the idea. We can make this a little bit bigger, and we can say, take that value, and with this equal sign, wherever you can say equals 0. And what this will do is turn it into an array of 1s and 0s. If that value is equal to 0, it will put a 1 in that array position. And if it's equal to not 0, it will put a 0. And so that tells you which one was 0. Right? We're starting to get closer to Fizzbuzz. We're doing modulus, basically. And then we're saying, is the modulus equal to 0? And so now we have an array of 0, 0, 1. And then what this does, this is using iota. And iota is the iterator. So if you say like I100 monadically, it will give you an array of 1 to 100. That's all it does. When you use it dyadically, it says, give me the position of the value in this array that is equal to 1. So it's going to go there and find position 3, and it's going to return a 3. And if it doesn't find it, it gives you 1. It gives you 1 plus the length plus 1. So it would return a 4. So this returns 3 because position 3 has a 1 in it, and the rest are 0. Now what we're doing here is we're using that entire expression as an array index with the square brackets. And then we have another array over here in parentheses. Parentheses do in APL what you think they do. They do what they do in math and in our programming languages. And so we're taking our one-based array, and we're saying, well, for the number 50, give me the index. It gives me a 3, and so 3 is buzz. So that pulls buzz out. And then the final implementation here takes all that, puts it in curly braces to make it a function, and then using dot dot and then iota, it says, run this function over the contents of this iterator, or over the contents of this array, and the array is 1 to 100. So this will run Fizzbuzz from 1 to 100. I totally stole this from this URL right here, but it's Fizzbuzz, so I don't feel bad about it. Thank you, codeburst.io/Fizzbuzz in APL-1A193. Anyhow. So who knew you were going to learn some APL tonight? I think we should build production systems in this. It's APL and regexes, and that's all we're going to use. The other question, yeah.
It seems to be saying that there's something special about someone where someone that functional, like not just functional, but like a usable language. And people will come in and presumably
Yeah.
what would you say about it? This history stops there and computers are kind of giving this history another way.
I don't know, honestly. I mean, I'm kind of thinking it might be something like this. This is actually more influenced by mathematics more than anything. And I think it's telling that when you look at, like, at least I know when I look at Japanese text, it's got Western style punctuation in it. So they're getting value out of those punctuation marks in the same way we are. So I'm not actually 100% convinced of my half-baked hypothesis. I don't think programming would have just fallen by the wayside. I don't think that would have happened at all because it's just too fundamentally useful. But yeah.
That's just like because I was born in Cincinnati.
Yeah. That's a tough question. I mean,
like scoping.
Well, it's not. I mean, there are plenty of programming languages that are scopeless. And in fact, if you go all the way down to assembly just has memory addresses, right? So there is no scope at all. A scope is a structure that we build on top of it to make it a little more useful. But the first programming languages I learned didn't have scope. What was your first programming language? Matlab? Okay. Yeah. Scripts tend to be, everything's globally scoped. I started with line number basic on a Commodore 64. And everything was globally scoped, and all the variables were, you had 2 letters, or a letter and a number, and that was it. And so, yeah, so scoping in particular, I don't think is essential, but yeah, I think anything that has a grammar basically becomes Turing complete. And so there's, the minimum viable programming language is literally the patterns of 1s and 0s that are the instructions. And we've built useful abstractions on top of that for us to think about them. And I think the useful abstractions we built on top of those are biased towards our language and culture. And I certainly think that like Asian languages would have had built things that were biased towards their language and culture as well. I think they would have been symbolic like this, but I don't know. I mean, I'm kind of talking out of my ass, right? So it's a fun thing to think about, though. So, yeah. Where would I place Lisp in the spectrum of my list? Probably somewhere just to the right of regular expressions, because it's pretty symbol heavy, but it's the same symbol over and over again. It's just like, like, yo dog, I heard you like programming, so I gave you parentheses. Yeah. So yeah, that's where I would put that. So yeah.
I don't understand with the comma 15.
It's just so in Fizzbuzz, when you hand a number, you return Fizzbuzz, or the number. The comma 50 is the hard-coded value that we're using that got replaced with the omega. So on this last line, I didn't mention this, the omega here, that means the argument that was passed in on the right. So, so what we're doing is saying, take these numbers, divide them by whatever argument was passed in, and then we have an array here that has fizzbuzz, fizzbuzz, and whatever argument was passed in. And so then the iota I1 is going to return 4 if they're all zeros, if there's no 1 in this array up here. So you're going to get 4 down here, and then that's going to be the 4th position in the array, and so then it'll return the number that was given. Yeah.
I mean, you could also see this as slightly different in English in that it seems to be object verb, the object verb subject. That the object is communicating is on the left and the verb in the middle of the function.
Yeah, you sort of end up like
and then the subject at the front.
Yeah, you kind of end up with a tree structure with this, where the verb's kind of in the middle, and then you might have a verb or a left or right of it's actually in this, it's like everything's a transitive verb, or not a transitive verb. It's all like all the verbs are like to be. Like where Guy is an idiot, right? They all have that sort of quality to them, but it does make a natural tree, which is actually, it's really more mathy than anything. But speaking of word order, what would it look like if the Romans had created programming languages? Romanes eunt domus. People called the Romans, they go the house. So the Romans had a highly inflected, Latin is a highly inflected language, but they still had a preferred order. So this is the node writes a byte in Latin. I went out and found a dictionary of modern Latin words. And octatus is the Latin word for byte. If you think of the word octet, which you may have run into occasionally, they just put a US on the end of it. Boom, it's Latin. And and this sentence is in subject, object, verb order. So node is the subject, nodus. That one should be pretty obvious, right? Octatum, I guess it'd be octatum in strict classic Latin pronunciation. Mrs. Nearhood would be proud of me. So the node, a byte, and scribit means it writes. So the node, a byte, it writes. The node writes a byte. But Latin doesn't care what order these words are in. All of these say the same thing, and they can be translated the same way. Every single one of these sentences says the node writes a byte. How many here studied Latin in school? 1, 2, okay. So how does Latin do that? All right, they use subject, object, verb generally, but they don't have to. They can switch them around any way they want. Well, it does it with inflections. Latin is full of inflections. You know how we change the ending of our words and verbs to make it past or present tense? So we add an S there for whether the subject is singular or plural. Latin does that with nouns too. So that US on the end of node, that means that us makes it the subject. On octatum, the makes it the direct object. By the way, both singular. And scribit, that IT ending makes it writes. So that'd be what? Yeah, third person singular, thank you. Had to stop and think about it. Makes it third person singular. This is why I like in Spanish. Spanish does this too with verbs. But in Latin, it's the same way. You can omit the pronouns, the subject when it's a pronoun, because the verb tells you what the pronoun is. So scribit could means it writes. And so if you just say that by itself, it means it writes. So you can say scribit octatum, and that means it writes a byte, or the byte. And so Latin has this whole system of declensions. where you can change the ending. So you can got these 5 tenses. There's actually a 6th that I didn't include in here what is it? Evocative, not evocative. Is it evocative? Yeah. It's the brute, et tu brute. It's the brute thing, right? I couldn't remember what it was called. So nominative means it's the subject of the sentence. And if it ends in US, that means a couple things. One, means it's the subject. It means it's singular, and it means it's grammatically masculine. No D means the same thing, but it's plural. Genitive shows possession. So that's like an apostrophe S in English. It's got some other uses, but generally. You might have heard the famous expression rex rexorum. That orum ending means of kings, king of kings. If you look at the dollar bill on the back of your, look at the back of a dollar bill. Let me see if I have a dollar bill in here. I'll hold it up to the camera. But on the back of the dollar bill, it says Novus Ordo Saeculorum. Saeculum means like an age or a period of time. And so it actually means new order of the ages, but it's usually translated as New World Order. And so, so when we're done, we're going to listen to ministry. So you've seen that before. That's what that means. Dative is just, it's the indirect object. That's, Alice gave Bob the book. Bob's the indirect object. Accusative is the direct object. And ablative is what you use in prepositions. And so this is how Latin does this. And this allows you to then put your words in any order you want. So you can put a word first to emphasize it. Or you can make your sentences dramatic by saying, well, we've got the subject. We know who did whatever it is that's going on. We know the direct object. We know who it was done to. And we know the indirect object. And we got these prepositions. But what happened? Verb. Right? So Latin tended to be written in that order because it makes sentences more dramatic. Did they talk that way? I think so. Graffiti. There's graffiti where people would write like they talk. But you can see how people in written text would be more inclined to write their text in more dramatic fashion. I do that myself when I'm writing, right? We want it to sound give it a little punch. So I think we have probably a biased sample of the Romans doing that because we have the passed down works. And so it's the thing people bother to write down. And then people bother to copy. Here's octatus, octati, octatorum. You'll notice that some of these are duplicated here. That's what happens in Latin, and context helps you figure it out. And so if we take that bit of code, the node writes a byte, or that bit of text. The node writes a byte. We break it up into its subject, its verb, and its object. And this is the English one, obviously. This actually directly corresponds to how we write code in a way that you probably didn't even think about. I've got an instance of a thing. That's the subject. I have a verb. I have a method I want to call. That's the verb. I mean, how many times have people told you the good coding practices is your method should be verbs or verb phrases of some sort? And then what does it operate upon? What does it act upon? That is literally the definition of a direct object, right? And so we have constructed our programming language such that the order in which we issue the commands are in the order that we use in English, in our positional grammar. If we do it like Yoda, we could change our programming language. If Yoda had created JavaScript, he would have done it like this, right? He would have put the direct object first, and then the subject, and then the verb. And if the Romans had done it, they probably would write it in the order they used most often, the order that was the most dramatic. The subject, the direct object, and the verb. But they wouldn't always want to do that. And this is the thing that I think is really cool. This is the thing that I discovered by putting together this talk and playing with it. The part that this is like the best part, in my opinion. And that's that the Romans could have written it all of these ways. And it works. And why does it work? Because we put inflections on our symbols. That's cool. Right? We didn't. And why did we put those inflections there? Because it makes it easier to parse. So when we have to write a compiler, we can look for the parentheses, and we know it's that part of the grammar. So why do human languages have inflections? I bet you it's the same reason. The Romans were using an order, but you don't always hear things clearly, right? And so if you double up that information and say, well, this is the subject, this is the object, this is the verb, and just in case you didn't hear clearly, we put some endings on there. So now you've got two pieces of information to make sure that the information is transmitted correctly. So they in other words, to make it easier to parse. And so we're doing the same thing. I just thought that was really cool. So that's, I think, the big insight for me in having done this exercise is you could write a compiler that could compile that. You would probably still need some sort of ending terminator, like a semicolon. But yeah, so that got me thinking, what would JavaScript look like if the Romans did it? So let's take our Fizzbuzz example, and just to be kind of fun and slightly ridiculous. We're going to take this code here, and we're going to translate it to Latin. So first off, the obvious low-hanging fruit, the things that we can do is we can change all of our variable names, our class names, our function names to Latin. So here we have Fizzbuzz. Our function becomes transforma. It transforms. Maybe it transforms. No, it'd be an imperative. And then numerum, which is the direct object form of number in Latin. And then we got, returns Fizzbuzz, and Fizzes. And so that's, and then here's our result here. Pass to be figured out that was the Latin word for result. I don't know if that's right or not. Current me is not so sure about that, but we'll go with it. We probably should replace our numbers with Roman numerals just because this would actually be really hard to write a parser for. I mean, to be fair. And I didn't know what the hell to do with zero because Latin didn't have a zero. They had a word for the nothing, but you could go like with, I think it was nullum and nihil. But A, that wouldn't fit on the screen. And it doesn't really capture the essence of it. So I just put zero in there. And then you can replace all the reserved words with Latin words that would be appropriate. So class becomes genus. That makes sense. Si is if, just like in Spanish. Volvitur means to return. Not exactly. It probably should be revolvitur, but again, it fits on the screen and it's close enough. Sit is let. Like you say, sit vis nobiscum, which is, I think that's let the force be with you in Latin, or may the force be with you. And then I used novat, which means it instantiates or it creates new, makes out of nothing, which is actually a really good word for the new keyword in a programming language. And then I'm like, well, let's go ahead and rearrange them so they're in the order the Latin wants them. And there is our Latin Fizzbuzz. Fun. And now we have proper Romans go home. That's my talk. Thanks a lot. My name's Guy Royse. Give me a follow on Twitter if you haven't already. I would like to say their code for this is on GitHub, but it's not because why? But yeah, that's all I got. So thanks a lot.
Thank you, Guy. That was awesome.